Welcome to qnawire.
Here in this problem, there are three parts, and in the A part, we have to calculate the final volume of the gas, and in the B part, we have to calculate the work done on the gas, and the C part, we have to calculate the energy transfer for the given condition. So the conditions are that there is a 2 mole of helium. So N is given as 2 mole, and initially its temperature is 300 Kelvin, and its pressure is given as P1 is equals to 0.4 atm, and the final conditions are, and it is compressed isothermally. Its isothermal condition is given, and the final pressure is 1.2 atm. So first of all, let us convert the atm into a Newton per meter square. So 1 atm is equals to 1.013 into 10 to the power 5 Newton per meter square. And similarly, we can write here also that 1 atm is equals to 1.01, it's 3 here, into 10 to the power 5 Newton per meter square. So after solving this, we'll get 1.21 into 10 to the power 5 Newton per meter square, and here we'll get 0.4052 into 10 to the power 5 Newton per meter square. So our first aim is to calculate the final volume of the gas. So since it is given that the temperature remains constant because it's an isothermal process, so we can write P initial V initial is equals to P final V final. But V initial we don't know, so we have to use ideal gas equation to calculate VI. Because it's a given, we can assume the gas to be an ideal gas equation, ideal gas. So we can write P initial V initial is equals to nRT. So here V initial will be equals to nRT divided by P initial. So N we are given as 2, and it's 2 mole here. Let me write the units also. And R is a universal gas constant whose value is 8.314 joule per kilomole Kelvin. Sorry, it's a Kelvin mole. And temperature we are given as 300 Kelvin. Divided by initial pressure is Pi, that is this one, 0.4052 into 10 to the power 5. From here we'll get the value of volume as, it's in Newton per meter square, as 0.123 meter cube. So this is the value of V initial. Now we're going to plug this value in this formula. So P initial we know it's 0.4052 into 10 to the power 5 Newton per meter square times V initial we know, we have calculated 0.123 meter cube is equals to P final, it is given as 1.21 into 10 to the power 5 Newton per meter square. V final we have to calculate, so from here we'll get the value of V final as 0.0410 meter cube. Next we'll be solving the B part of the question. Now in the B part we have to calculate the work done on the gas. So work done in case of isothermal process is given by the formula minus nRT natural log V final by V initial. So we have all the values here. So N is 2 mole, R is 8.314 joule per Kelvin mole, and temperature is given as 300 Kelvin times natural log V final we have calculated as 0.0410 meter cube divided by V initial is 0.123 meter cube. So we're going to simplify and we'll get the result as 5.48 kilojoule. and remember it's a plus sign should be there, because this minus and natural log will get the value as negative sign, so minus sign will become plus. So this is the work done on the gas. In the final C part, we have to calculate the energy transfer. So we'll be using the first law of thermodynamics, that energy transfer by heat, so that is change in internal energy is equals to Q plus W. So since it is given that it's an isothermal process, so change in internal energy for ideal gas in case of isothermal process is 0. So we can write Q plus W is equals to 0. Now we're going to plug the value of Q here. So we'll get the value of Q as minus 5.48 kilojoule, because from here Q will be equals to minus W. W we know. So this is the final answer for the C part. So I hope you got the problem.